Dr. Ed Hawkins, welcome to the Climate Pod.
Well, thank you for having me.
The IPCC recently released its new report, Climate Change 2021, the Physical Science Basis. Why are assessments like the report released today an essential part of the conversation on climate change?
So it's important to realize that climate change is an enormous endeavor, and the science behind it is an enormous endeavor. We have to come together every few years and assess our understanding and assess our knowledge, because that is what is asked for by the policymakers. And so the IPCC isn't the scientists, it's actually the 195 governments that make up the IPCC. And they request these reports to guide their discussions about climate policy. And so they ask for these reports every few years. The scientists go away for 3 years and assess all of the latest evidence, come back with a very large 1,000-page report, which we then write a summary of. And specifically, this summary is for policymakers. It's not a summary for the media. It's not a summary for the public. It is a summary for the policymakers. And so they guide what information they need to inform their policy discussions. And right at the very end of the process, over the last 2 weeks, in fact, the process we've gone through is all 195 governments coming together virtually this time for the first time ever to discuss the summary for policymakers and agree to it line by line, literally going through word by word and ensuring that the policymakers are content that every word is an accurate summary of the underlying science that we're assessing.
I have to imagine policymakers want to know one of the big questions, which is how much has the world already warmed? According to the report, how much has the world already warmed?
So the last decade is 1.1 degrees above the late 19th century, which is roughly pre-industrial. And of course, pre-industrial is very relevant to the Paris Agreement for limiting global temperature change.
And the big next question is, how much of that does the IPCC in this report attribute to human-caused warming?
All of it.
Well, looking at the contributions to global warming, methane is responsible for about 0.5 degree, and carbon dioxide is responsible for about 3/4 of a degree. We talk a lot about curbing carbon dioxide emissions, but what should we understand when it comes to curbing methane as well?
So yeah, you're absolutely right. Carbon dioxide is the biggest contributor, and methane is the second biggest contributor. And so reducing methane is as important as reducing carbon dioxide. If we are to limit global temperature rise, then all of the greenhouse gases, their emissions need to be reduced. And the key thing about methane also is that it contributes to bad air quality. And so as we reduce methane emissions, we also improve our air quality. And air quality is one of the biggest killers that we have. Bad air quality kills millions of people around the world. And so as we reduce methane for climate reasons, we're also improving our air quality at the same time. And so it's a huge extra benefit of doing that.
What was your focus in the report?
I was an author on chapter 1, which is the introductory, the context and the framing for the report. And so we discuss a lot about the history of climate science in particular and how long we've known what we've known, going back all the way to the 1820s when Fourier recognized there must be a greenhouse effect, and coming all the way up to the present. And so that's a critical part actually of the basis of our understanding. It's rooted in 19th century physics, what is going on today. It's very, very well understood there was a greenhouse effect all the way back in the 1850s and 1860s. And we're seeing the reflection of that today as our confidence has built over the subsequent time.
A big influence on this podcast getting started was that 2018 special report by the IPCC. And obviously in the Paris Agreement, we go back to 2015, the aim was to keep warming well below 2 degrees Celsius, right? Preferably at 1.5 degrees Celsius. When it comes to the question of whether we can actually keep warming at 1.5 degrees Celsius, if that's still possible, what does the report find?
So the report very clearly says that when we reach net zero greenhouse gas emissions, temperatures will stabilize. And so we haven't reached 1.5 yet. And so it is still possible to limit temperature rise to that level. But that does mean if we are to achieve that, we need to reach net zero greenhouse gas emissions by around about 2050 or very soon afterwards. And so that's a huge effort to essentially cut all of our greenhouse gas emissions out in the next 30 years.
Yeah, let's take the flip side of that. Let's say we don't cut out all of our greenhouse gases in the next 30 years. How plausible is it that we can actually exceed 2 degrees of warming Celsius?
So again, it all depends on how much carbon dioxide we put into the atmosphere. The more we put in, the warmer it gets, and the more severe the consequences. And so the positive message from this report is that because climate change is because of humans, it means our choices determine what happens next. We have the choice about where we end up in terms of global temperature rise.
Well, with our current trajectory of warming, what did the report outline when it comes to the effects of climate change that we are likely to see just in the near future?
So I think one of the other key aspects of this report is that it really highlights that even at 1.1 degrees now, we are seeing very clearly changes in extreme weather. So it says very clearly again that we're seeing heat waves get more frequent and more intense across most of the planet. We're seeing more extreme heavy rainfall events, again, over many regions. And in other regions, we're seeing increasing droughts. And we can also attribute those changes in many cases to human actions and human influence. And so we're very clearly saying that human actions are already affecting these very severe weather events, which have enormous impacts on people and society and ecosystems. And as the planet continues to warm, those impacts will just get worse. Those events will become more frequent and more intense as the climate warms.
Well, the report notes that human influence has likely increased the chance of compound extreme events since the 1950s. So what are compound extreme events?
So compound events are events where you have 2 or more things changing at the same time, causing a third thing. That's one example at least. So the most obvious example we could talk about today is fire weather. And we're seeing enormous wildfires in the Mediterranean, Greece and Turkey at the moment. And obviously there have been enormous wildfires in Australia and obviously in the Western US as well. And in many of these regions, what we're seeing is that they are drying overall, but they're also getting more extreme heat. And so those factors combined compound together to make fire weather more likely. And therefore, if there is an ignition source, then those fires are more likely to happen. So it's those type of compound extreme events. And another example would be sea level rise coupled with tropical storms and hurricanes, for example. So sea levels are rising around the world and around our coastlines, which means that when a hurricane hits, for example, sea levels are already higher. And so there's a higher storm surge associated with that storm. And this report also highlights that we expect intense tropical storms to become more frequent, more intense, I should say. The storms will become more intense, which means that more winds and more rainfall from those storms. And so all of these factors combined mean that the effects of that storm or hurricane are worse than they would otherwise have been.
Let me ask a very basic climate science question, which is kind of, this is often my role on this podcast. In the report, we talk about, how human-caused climate change has significantly increased heavy precipitation in some areas, but also increased drought in other areas. And as a layman to this, I'm looking at that and saying, well, how is that possible? Why is it that some areas are experiencing excess rain while others are drying out?
That's a great question. So as the planet is warming, it means that the circulation in the atmosphere is shifting slightly. And so that means overall, some areas are getting drier, such as the Mediterranean, for example. But at the same time, what we're seeing is as the planet warms, we get more evaporation of water from the oceans, and the atmosphere is also warmer as well. And a warmer atmosphere with more evaporation means there's more moisture in the atmosphere. The humidity of the atmosphere is seen to be going up, which means there's more water in the atmosphere. So when it does rain, it has the potential to rain a lot more. And the report says that we expect to see 7% more rain from these storms when they happen per 1 degree of global warming. And so when we get these storms, you get more intense rainfall. And so you can actually have situations where overall the situation may be getting drier in some regions, but when it does rain, it will rain more.
One of the things that I find scariest about the climate crisis is the idea of the Arctic losing sea ice. Like that just seems astonishing to me, right? That's even possible. And in the report, it talks about the Arctic is likely to be practically sea ice free in September at least once before 2015 under the five illustrative scenarios considered in this report. What does it mean for the planet if the Arctic is free of sea ice?
So what it means is that, for example, if you remove the reflective surface of the sea ice is very reflective and would normally reflect sunlight back into space. But you're removing that mirror, if you like, and you're exposing the ocean, the darker ocean beneath, which means that less sunlight is reflected back into space from the sea ice, which means that more energy is absorbed by the Earth, and that amplifies the warming. And so that's one of the reasons, not the only reason, but one of the reasons we're seeing the Arctic warming faster than anywhere else on the planet. And it continues to warm twice as fast as the global average, at least. And of course, this has enormous implications for the ecosystems and the people who live in the Arctic. It's exposing coastlines that would normally be locked in ice, but now they're exposed to waves. And so you're seeing coastal erosion, as well as the effects on the people who live there and the wildlife as well.
And I think that example speaks to a larger issue, which is, are we going to trigger tipping points in our climate system that cause irreversible damage? When you look at this report with regards to tipping points, what were you finding? What kind of dangers are we potentially facing in the future?
So tipping points are much discussed through the report. They're clearly a very, very important topic. And often in scientific terms, tipping point is a very specific definition. But we talk a little bit more broadly about the concept of surprises and abrupt changes and large changes in the summary for the first time. And so we actually highlight what we call low likelihood, high impact outcomes, which is basically a worst case outcome. And so we discuss some of these possibilities for what would be a worst case outcome, which are perhaps unlikely, but if they were to happen, it would have really quite significant effects. And so for the first time in one of the key figures in the summary for policymakers, one of these outcomes is highlighted, and that is the melting of the Antarctic ice sheet, the potential for very, very rapid collapse of the ice sheet and ice cliffs. And so that unlikely but plausible outcome would cause up to 2 meters of sea level rise in this century, which is an enormous amount, and many meters beyond that if it were to occur. It is assessed as being unlikely, and that's important to note, but it is one of the worst case scenarios that we want to highlight to decision makers, because it informs decisions about risk assessment.
Well, it's been 8 years since the last IPCC assessment on the science of global warming. What do you see as some of the advancements in climate scientists have made that are reflected in this report?
So I think one of the key issues for this report and the key advances is this knowledge about regional changes in extreme weather. And that's a really key advance. We are now looking at smaller scales and seeing the changes very, very clearly in extreme weather already. And we make very detailed assessments regionally, again, about how those extreme weather events will change in the future. And there's actually a much broader assessment of the types of effect we expect to see at smaller and smaller scales, and how climate impacts will be distributed around the planet, because not every region will experience the same effects. Every region is slightly unique in the way it will experience climate change. Some regions will be more exposed to sea level rise than others. Some regions will be more exposed to changes in tropical storms than others. Some regions will be more prone to extreme heat waves, causing problems for how we live in certain regions. Other areas the biggest risk will be changes in extreme rainfall. And so all of this has to be picked apart for decision makers so they can understand what's happening in their own region and make required decisions about how to adapt to climate change, because that is now inevitable. We're already seeing changes. More changes are inevitable, and so we have to change the way we live to deal with those consequences as well. And so all of that detailed assessment is a real advance, I think, on the previous report.
Let me ask another dumb climate science question, which is about climate sensitivity. This is the thing we've talked about on the show before, but it's an incredible concept for me to try to understand. As we put carbon dioxide into the atmosphere, how much is that actually going to warm the planet? When it comes to climate sensitivity, what does this report have to say? Because that's obviously a big part of some of the advances we've had in climate science in recent years.
It is, and so there has been a big advance, I think, over the last few years in our understanding of how the climate responds to emissions of carbon dioxide. And again, I think one of the key advances in this report is that we're bringing more and more multiple lines of evidence together to make these assessments. And so for the climate sensitivity assessment, we're bringing in information from climate model simulations. We're bringing in information from physical process understanding, and we're bringing in information from changes in past climate from the deep past, and bringing all of that information together to make a much broader and multiple lines of evidence assessment. And we've managed to narrow the range for the assessment of climate sensitivity this time, which is a great advance, I think. And that change means that our projections of future changes are also a bit narrower. We've got more confidence in what will happen to global temperature, for example, and for sea level rise, and for changes in ocean temperatures. These have all been brought together, assessing multiple lines of evidence together. It's not just the climate models anymore. It's bringing multiple strands of evidence together to improve those assessments.
Well, one of the data points that stood out to me is the fact that due to the burning of fossil fuels, humans have actually contributed as much as 2 degrees of warming to the planet. However, the planet hasn't warmed that entire 2 degrees because of aerosols. Can you explain how aerosols have actually helped cool the planet over time?
So that's right. So our understanding is that the greenhouse gases we put in the atmosphere have caused more warming than we've actually seen. But some of that has been offset by the fact that when we burn fossil fuels, we also produce small particles which end up in the atmosphere. And those particles help reflect sunlight back into space, for example, and interact with clouds in very complex ways. And our assessment overall is that the effects of those pollutants in the atmosphere, they're actually a cooling influence on the atmosphere. And that offsets some of the warming that comes from increasing greenhouse gases. And we've seen this actually in the past, back in the 60s and 70s. It was realized that these pollutants in the atmosphere are very bad for human health, and the air quality issue again. And so in many parts of Europe and the US, the Clean Air Acts came into being, which cleaned up a lot of the output from the power stations at the time, which meant our air was cleaner. And that actually meant that the global warming accelerated a little bit at that time because of that cooling influence was removed. And now we see that a large fraction of these particulate emissions actually come from Asia and other parts of the world now, instead of Europe and the US.
Well, this is a massive report written by hundreds of scientists. You were a lead author on this report. What was it like working with so many scientists across over 195 member countries?
So that's right. So it's been an amazing experience to be part of. It's been 3 years of very hard work. So the particular chapter I was part of, we had about 16 authors from all over the world. We had authors from Africa, from South America, from North America, from Europe, from Asia, and from Australasia. So covering every continent, and most of whom I'd never met before. And so that was fantastic. First of all, to meet new people, to get involved and write this report together, but to hear about other perspectives, and especially from the developing world, where we don't always hear as much as we would like to. And so that's been a fantastic experience, to bringing all of these expertise together to write this report. And I think it's also worth emphasizing that the report gets reviewed by thousands of other experts as well from all over the world. So it's the 230 something authors, as well as the thousands of reviewers and other contributing authors, which ensure that the report gets written, along with support from the technical team behind this, as well as our advisors up above. And so it's an enormous team effort.
And this, for climate scientists, is an extraordinary. You seem like a very humble guy, but this is an extraordinary amount of work and a real sacrifice to invest a lot of time in this, right?
That's right. And we're all volunteers. And I think that's worth emphasizing. We don't get paid to be IPCC authors. We have to either do it as part of our day job, if we're lucky, and our institute will remove some of our other responsibilities, or we have to do it in our spare time. And for most of us, it's a combination of those two. We certainly have added hours. And I think the pandemic has also made that situation worse in many ways. We've had to, instead of meeting in person once for the last meeting, we had to do everything remotely with all of the complexities of different time zones. And so that meant a lot of late nights and early mornings for many of the authors to try and have these very difficult conversations about writing the text and making sure that everything was as precise as possible. And so it is an enormous effort. It has been delayed a few months because of that. But I think having it online has also improved things in many ways because it was done a little bit slower. It gave everyone a little bit more time to think about it and actually hear from other views and ensure everyone's views were represented. So, it's been a great experience to be part of.
Well, you have contributed so much to the field of climate science, but you are internationally known for the warming stripes. So I'll let you take it from there. What are the warming stripes, and what made you want to create them when you did?
So the warming stripes are essentially the simplest representation of changes in temperature that I could think of. Often when we're talking broadly to the public, for example, we're talking to people who don't have a background in science and, were maybe turned off science at school, for example. And so we have to communicate effectively with everybody if we are to tackle this problem. And so it all started, actually, I was giving a talk at a literature festival, which is not normally a place you would find a climate scientist. It's called the Hay Literary Festival, which is a very famous literary festival in the UK. And they, for the first time, had very bravely brought together some environmental scientists with authors and poets to put together an event at the festival. And so I was partnered with an amazing poet called Nicola Davies. And as part of that, I wanted to come up with a way of communicating to an audience who wouldn't normally see any climate science. And so I chose to try and represent the changes in temperature in the town of Hay with just some simple coloured stripes. So blue stripes being used for cold years and red stripes being used for hot years, and varying shades of that colour in between depending on how hot or how cold it was. And it was just a very colourful, simple, powerful, visual, stark representation of the changes. And it was very clear as soon as I put the graphic up on the screen, you could see people's eyes open and realise that actually, even in a small village in the middle of the Welsh countryside in the UK, the change in temperature was clear. At the scale of a single village, you could see that that village had warmed up over the previous 100 years. So it communicated the fact that climate change is not just a global problem. It's happening globally, but it's happening everywhere. And we're all being affected. And making that connection to local people and making the local scale and making it relevant to people, I think, was a key aspect for why it works, I think, as a communication tool.
Yeah, absolutely. And I think in this IPCC report, they're trying to tie in the idea of regional impacts, and by having that tie-in, right, you're getting more people invested in the climate crisis. Now, this report is for policymakers, as you mentioned. When you look back at the climate strikes, the success you had, what can we take from that to have more communication successes with the climate crisis? Because as you mentioned, we have to get everyone involved.
We do have to get everyone involved. And I think as Catherine Hayhoe, you probably may have had her on the podcast, she often talks about the fact that we need to get people to talk about climate change and the climate crisis. And that is the key thing we need to do. We need to get this part of the normal conversation. We need people talking to their friends, their family, their colleagues about climate change, about the implications for individuals locally. What does it mean that the climate is changing locally? Is it the fact that we're getting sea level rise around the coasts giving increased risks for people, or is it the heat or the fires? Everywhere has a different story to tell about the risks that we face. And so communicating that and getting people to talk about it is essential. And the stripes offer a very simple way of starting those conversations. They've been used and adopted and used in so many novel ways to have conversations, from people knitting them. And that's been an enormous effort. You've seen people everywhere knitting the stripes and wearing them and giving them to family and friends. We've seen people paint their cars with the stripes and use them in logos and on badges. So some of the US senators wore the badges in the State of the Union in 2020, which was fantastic to see. So they offer a way of communicating a message and starting those very, very important conversations.
How has it made you feel to see that?
It's been incredible to see how far they've spread and the novel uses. And I think that's been particularly pleasing. The graphics are made available freely and openly for anyone to do what they want with them. And just the creative uses, they've been in museums, they've been painted on trams, on cars, on buses, on walls all over the world. In protests, people have used the stripes as a way of communicating messages. And it's just been great to see how people have adapted and adopted them as a symbol of climate change. And that's been brilliant.
Oh, absolutely. And like you're saying, like actual policymakers will wear their stripes. And, like just going back to the very beginning of the conversation, as you said, this is a report for policymakers. Policymakers have major decisions to make, and domestically and on an international scale in the rest of 2021 alone. When you think about what's included in this report, what do you hope policymakers will take away from it?
They need to take away that the risks are only going to get worse. So the slower we act, the worse the consequences, and the faster we act, the less bad those consequences. And they are very difficult decisions about what we do, right? It is not easy to wean ourselves off fossil fuels. That is very, very difficult to do. We have a lot of the technology available to us, but it requires very difficult decisions at government level, at city level, at industry and at company level about what to do. It's a whole global problem. And how do we act in the developed world and the developing world? We need to potentially enable the transfer of technology to others to be able to use the technology to reduce their own emissions. And it's an incredibly complex set of questions. And those are questions that scientists can't answer. We can provide the evidence to them about how bad things might get if temperatures continue to increase, and they can then make decisions about how fast to act.
And policymakers have a role in telling their constituents about and helping to inform them of these problems so that solutions become easier. Climate science is hard to understand for the general public. It's really incredible work that you do. When you think about the broader public, because this is going to be a huge news story today, when you think about the broader public, is there anything that you hope that in addition to that they'll take away from this report?
So if we tackle this crisis, it is going to require a transformation of society. It means changes to the way we live, how we travel around, how we heat our homes, what we eat, for example. And these are enormous changes which may or may not be popular. But the important thing is that often these changes will come with other benefits. So as we reduce our emissions, it improves our air quality, and that will have enormous effects. And I think that certainly here in the UK, the pandemic illustrated that very, very clearly. People noticed that the air was cleaner when cars were not on the road, when we had our pandemic lockdowns. People could breathe the air differently. And so they realized actually that our actions are actually affecting what's going on. And I think that was a very, very important message that came out of the pandemic, that these are critical issues and we can clean up our air, which has enormous benefits. So there are other benefits to society from making these changes, as well as just stopping the climate consequences get worse.
3 years of work on this. We know there's more of the report to come, but obviously this is good. This is rolling out now. It's out in the public. How are you feeling now that your work is actually out there?
Exhausted. So, the last 2 weeks, we've been locked in Zoom calls for significant parts of the day, discussing the summary word for word with 195 governments. That's been an exhausting experience. It's been a brilliant experience to see how involved the government delegations have been in ensuring that they get the information that they need. And they do scrutinize every word and ensure that it is as clear as possible for the information they need. And so that's been very reassuring to see that every government has got involved, every government has approved every word. And so when they go to COP, they have the evidence, they understand the evidence, and they have agreed to that evidence, that this summary is an accurate summary of all of the science that we've done and assessed over the last 3 years. And of course, it is an enormous team effort, right? There are thousands and thousands of people involved. These are probably some of the most time-intensive books ever written. It is that level of involvement from thousands of scientists all over the world.
Well, Dr. Ed Hawkins, truly an honor to talk to you. Incredible work. Thank you for all of your hard work on this report. We know what an incredible sacrifice this is, and how important it is for people like us. So hopefully after this conversation, our listeners will check out the report, but also find more creative ways to show their warming stripes. So we'll link to that. We'll link to the report and how that people can find their warming stripes as well. Dr. Hawkins, thank you again for joining the Climate Pod.
Thank you much for having me.